Okay, good morning, everyone. How did the homework go? Did you guys have any questions about the worksheet I gave you? Please go ahead and put your questions on chat or mute yourself and tell me your question.
Yeah, so was there a particular area to upload pictures of the worksheet on Brightspace?
When I give you a homework myself, you don't have to hand it in. You only,
Okay.
The only grade will be on what I give you on my lab. All right?
Okay, all right.
But those are important because I will be testing you on it, but I don't have similar problem on my lab to assign. So that's really the issue here. Okay.
Okay, thank you.
Sure. So I see 2C. C and 4C. Okay, we can do that, and 3A. Very good. So we do C, and the idea here is just to remind all of us basically the property of exponent. So let's do that. So I assume, so you did not ask about that. So it means I'm assuming everybody was able to do it. So let's see, what is the value of the box in A? Can you please give me the answer? Just put it on
5/6.
what?
Repeat. 5/6.
5/6. Okay, let's see. I'm sure he is correct because once we write it in fractional exponent, the idea is nothing more than adding the exponent. So it's a half plus a third. It means x to the 5/6. Okay. So that was a simple one. And what's the box in the second one? Go ahead. 7/2. Elizabeth is telling me 7/2. I'm sure she's right because this is x to the power 3 minus a half. It means x to the power 3 plus a half. 3 plus a half is 7/2. Very good. So now C, give us a little bit of a headache. Anyone got any answer? Somebody give me 3/4. Okay. All right, so let us see where C is. So let's rewrite it. Square root of x times root x, it means x times x to the power a half. Correct? Yeah, of course. It means that's the square root of x times x to the power a half. We add the power, which gives me 3/2. But what's the square root of that? What's the fractional exponent? This is x to the 3/2 to the power a half. Very nice. Now, this is 3/2 to the half. What do we do with the power now? That we multiply the power. 3/2 multiplied by a half give me 3/4. So she's absolutely correct. And the answer is the box is 3/4. All right. If you have any questions about it, please let me know. So it's a little bit of algebra. Now, okay, Zach is giving me the last one, which is correct. So what's the box in the last one? So this is 1 over e to the x squared. We multiply because as I reminded you yesterday, this is multiplication. So that's e to the 2x. 1 over e to the 2x is e to the minus 2x. So my box here is minus 2x. Sorry. Very good. Now, the other questions, I'm looking at them. 2C, we've done that. 4C, okay, and that's it. So let's do 4C. That's 4 and C. Okay, so C is, let me rewrite it because it seems to me it's not very clear. So this is my f of x. It's a piecewise defined function. It is x squared when x is negative. It is 3x, so it's a typical piecewise defined when x between 0 and 1. And it's exponential when x is bigger or equal to 1. Okay, and the question is just graph it and find the range and the domain. All right, so it's like 3 pieces. And we're going to sketch every piece by itself. Right. For x negative, it means when x in here, that's x negative, The function is x squared. X squared is, we know what x squared is. X squared is a parabola, that's the x squared. But now I'm interested in it all the way up to 0. It means I have to stop here at 0. And the 0 is not included. So we're going to have open here. So this is x squared. We know how to graph that. So it's open here and it goes all the way down. Now that's the first piece. So this is the x squared piece. Now, okay, do we have to turn there? I think we addressed that. Now, between 0 and 1, it's 3x. So this is a 1. And between 0 and 1, it's 3x. So from here to here, it's 3x. Now, what is 3x? We know what 3x is. That's a line. And let us do that. If x is 0, so 3x is just a line. At 0, it is 0. At 1, it's 3. And it's just a straight line. That's the line. But I'm interested in it only between 0 and 1. So that's the only piece I really care about. So at 1, it should be 3, but 1 is not included. 0 is included. If x is 0, so the circle here, I have to close it back in, and then I go all the way up. Okay? Finally, half x. What's the graph of half x? That's a typical exponential function. The base is a half, which is less than 1. So we know, yesterday we discussed this. If the base is less than 1, the graph looks like that. So this is a half to the power x. Now we know that we're not interested in all the graph. We're interested when x is bigger than 1. So we're interested in it here. For x greater or equal to 1, we're interested in it. So for x equal to 1, the output here is a half. So now how are we going to reflect this here? I'm only interested in this piece of the graph. So at 1, if x is 1, a half to the power 1 is 1. So let us say this is a half. So I want right here. This is included. And after that, the graph goes all the way down. Okay, so these are the 3 pieces of the graph. Right? So now the domain here is all of x's. Now the domain, all real numbers, there is no restriction. Okay, and the range, we always figure it out from the graph. The range is, what's the range? Put it on put it on chat. What's the range? The range, 0 infinity, is it closed? Is 0 included? Absolutely, because 0 is the output here. If x is 0, the output is 0, so 0 is definitely in the range. So it's closed at 0 and open at infinity. Okay, and this would make this the graph. Right, any other questions before we go any further? Very good. Okay, so this take care of really basically most of it. And a problem like B, which is 4 minus 0.4 to the x. Now, graphs like this, I actually don't want you, the only way I would like to do those graphs is basically stretch and shift starting from a known graph. So in this one, for example, we start with 0.4 to the x, which is an exponential with base less than 1. And then, so here, start with y equal 0.4 to the x. After that, we reflect across the x-axis, and this would give me the minus 0.4 to the x. And then shift up by 4. I think that we done with it in class. And this would give me basically minus 0.4 to the x shifted up by 4, which is the same thing as 4 minus 0.x, which is my function. So that's really how we would like to proceed. So the graph would be 0.4, go like that. That's a 1. Minus 0.4 is gonna, this would become minus 1. The shifting. So the shifting, this asymptote will be shifted by 4 units. So it's going to be right there. And then this minus 1 is going to be shifted by 4, 1, 2. So it's going to be somewhere at 3 here, and everything will be shifted. So we'll be creating this graph. And now once we have the graph, we can find the range, which is minus infinity up to 4, and that would be my range. Any other questions before we proceed? So as I repeat, I'm looking at the chat. Those, you don't have to hand them in, but you will be tested on them. So make sure you do those type of problems. Very good. So today we will, as I said, we're reviewing the basic concept of pre-calculus. So today we will review the inverse function, and tomorrow we go through the logarithmic function. So the inverse. We're still in section 1.3 because those sections have a lot in them because they are basically reviews. So we're still with section 1.3, and we will study the inverse function. What do we mean by the inverse function? All right, the idea is this one. Let us say I have a function f. Now, I'm just going to give it by a table just to make the scenario easy. So this is my function. That's the input. So those are the input values. And these are the output values. And let us say, I'm just going to make up numbers. So my domain is, let us say, 1, 3, 5, 7. So this is my domain, a bunch of 4 numbers. And my function does the following. It assigns to 1, let us say the number 3. It assigns to this one, let us say the number 7. I don't have really any order in here. It assigns to 5, let us say the number 10. And to 7, it's going to assign, let us say, the number 12. So that's really what the function do, nothing really deeper than that. Now, what is the inverse of f? The inverse is a new function. What it does? The inverse is a new function, which is gonna take for input the output of f. So these are the input of it, and it will associate or it will assign to 3 the number 1. That's f inverse. So it will assign to 7, 3. So it goes backward. It is assigned to 10, 5, and it is assigned to 12, the number 7. So that's really what the inverse. So the inverse is a function. It's a new function that takes the output of f as input and assign to every output value the input that comes from. So, and it has a specific notation. It's denoted by f inverse. So what f inverse does, let us understand it. It takes 3, that's a new function, and assign to it what that 3 comes from. Assign to it 1. So it goes backward. It takes 7 back to 3. And it takes 10 back to 5. And it takes 12 back to 7. So let us define the inverse. So what is the inverse? So suppose f is a function. F inverse is the function. And we will discuss a little bit more later this word. It's the function. Defined by, how is it defined? So whenever I have a function, I tell you how it makes sense. F inverse of a number y is the value of x, such that f of x is equal to 1. So f inverse of 3 is what? It's the input value of f such that f of x such that f of x is equal to 3. So what's f inverse of 3? You ask yourself, which input will give me 3, which is 1? F inverse of 7, which input of f will give me 7? It's 3. So f inverse of y equal to x means that f take x to y. So that's really the relationship. Okay. Now, so in a picture format, how would we? What does f inverse does? So we have the function f. F take x to y. What f inverse do is basically undo what f does. It takes y back to x. That's really the picture of f inverse. So f inverse does this function. Let us say we're going to take a lot of examples. Suppose I take the following example. Okay. So I'm going to take a function this time, and I'm going to graph this function. So let me take a graph. That's my function right there. And let us say this is 0. So I'm going to make a simple graph, nothing deep. So you guys, so this is a 2, let us say, and this is a 4. So that's my function. And I'm going to like make it like that a little bit. So I'm going to put here a 4, and I'm going to put here a 6. Okay, that's my function f. This is x, and these are the output of f. So the domain here is from 0 to 4 for f. The range is from 0 to 6. Okay, and we're going to start asking some questions about f at f inverse. So very straightforward question. Suppose I tell you what is f of 2. Very simple question. All right, you guys give me the answers on 4 immediately, because it's f of 2. Okay, that's here. This is equal to 4. Okay. Now, what is f inverse of 2? What does it mean? Find f inverse of 2. Okay, find f inverse of 2. So find f inverse. What does this mean? It means we need to find the input x. That's really what it means. That spits out an output of 2. So the input of the f inverse, those are the output value of f. So finding f inverse, it means which input give me an output of 2. All right, and I'm seeing a lot of you are giving me 1. Absolutely correct. Let us see it on the picture. What is f inverse of 2? It means this is 2 right here. Now 2 is an output value. And what I'm asking, going backward, I'm asking you for the input that gives me an output of value. That's the f inverse. Now if we look, so that's the f inverse of 2. And if you look at the picture, that seems to be a 1. All right, so the inside, the domain of the f inverse are actually are output values of f. All right, so let us do 2 more questions along those lines. So what is f of 4? Let's see, anyone? What is f of 0? No, I don't want that. That's easy. What is f of 4? According to my picture, what is f of 4? Absolutely 6. And let us say, what is f inverse of 5, for example? What's f inverse of 5? 3, is she correct? What's f inverse of 5? All right, I'm a bit slower than Elizabeth. So this is my 5 here. What's f inverse? It means I go backward. What's the input? That gives me s. So finding f inverse, it means we need to find the input whose output is x. Okay. And from the picture, of course, we know that f inverse of 5, according to my little graph, is equal to 3. So this is really, it's a new function. It's an absolutely new function. How is it related to f? Is actually its input are the output value of f. Now, what's f inverse of 7? What's f inverse of 7? Sorry. Undefined? Do you agree with her? Why it is undefined? 7 is here, up here. Can you give me an input where the output is 7? Absolutely not, because there is no input such that the output is 7. So f inverse of 7 is absolutely undefined. All right? So let's talk a little bit about the domain and the range of f inverse. The domain of f inverse. What's the domain? It means what are the output, the input values of f inverse. So the domain of f inverse in this picture, what is the domain? Everything basically in the range of f is in the domain of f inverse. So 0 is in the domain, 2 is in the domain, 4 in the domain, 5 in the domain, and 6 in the domain. So the domain of f inverse, because f inverse take for input those output value, so this here will be the domain of f inverse, because that's where it takes its value. So the domain of f inverse is basically the range of the function f. So the domain of f inverse is actually, in my scenario, 0 all the way up to 6. That's the domain in my scenario. Okay? And so in general, we have the following. The domain of f inverse is always the range of the original function f. The range of the original function. So the domain of f inverse is the range of the original function. Now, as I said, the inverse, f inverse is the function defined by follow. Sometimes f inverse, a function does not have an inverse. So let me take a simple scenario. Suppose I have the following situation. This is the function f. A very simple function. All right, suppose this is f. This is my function f. And the question is, so this is 1, this is 2, this is 3. Let us say this is 1. So I'm just making up stuff, as you realize. So this is like -1, and this is 2, and this is -2. Okay, so that's a function that I made up. So my question is, find f inverse of 2. If possible. So what would be your answer? And it has 2 possible solutions. Is Elizabeth right? And Luke tells me 1 minus 1. Is Luke right? What do you think? Okay. What's this mean finding f inverse? It means we need to find the x value, the input that spits out an output of 2. That's really what it means to find it. Now, as you realize, if we take 2 in here and I go backward, because that's what f inverse is, the idea of going backward. So if I take 2 in here, and then as you realize, then I have 2 x's, 2 input that give me an output of 2. So the f inverse of 2, it means it spit out 2 values. So f inverse of 2 in this scenario is 1 or -1. But f inverse is defined to be a function.
I'm going to do something very brave right now, so be ready to stand up and give me a round of applause for this. This is going to take a lot of courage, and I just think it's something that needs.
Okay, all right. So we have to find f inverse of 2. It means we have to find the inputs at fx equal to 2. According to my picture, f inverse of 2 is 1 or -1. But f inverse is a function. Is a function. A function cannot give me 2 different values for the same input. So this is a scenario where the inverse do not exist. So this function f does not the inverse does not exist. And this function, we say that does not have an inverse because it's not a function. So f inverse here do not exist because here f inverse, because it's not a function, because the input of 2 has 2 different outputs. The input of 2 has 2 different outputs. So not every function has an inverse. Some don't, and this is a typical example of a function that doesn't have an inverse. And this idea brings up the definition of something we call a one-to-one function. So what is a one-to-one function? So I will define it. One-to-one function. Okay, what's a one-to-one function? A function is called one-to-one if the following. If this does not happen. So a function, we call it one-to-one if no two different input of f give the same output. A function f is called one-to-one if no two different input of f will give me the same output. That's what a one-to-one function. Let's write it down a little bit. So the idea is simple. So f is one-to-one. So let f of x be a function. We say that f, function f, is one-to-one if no two different input of f have the same output. No two different input have the same output. So this is in words. So mathematically we would write f is one-to-one if. So this is in word for us to help us understand. But in math we say that f is one-to-one if whenever two inputs are different, if whenever two inputs are the same, different, their output have to be different. There is no way they can be the same. So that's how we write it in more mathematical way. So if the input are different, the output have to be different. That's really the idea. Okay, so a function is one-to-one if this scenario doesn't really occur. It means I don't have two different inputs, same output. So graphically, it's very easy to see whether a function is one-to-one or not. So I will draw like fairly 3 graphs, and for each one, you have to decide very simply if the function is one-to-one or not. So let us graph, for example, let me take this function. And let me take this function. And each one of them we're going to answer. And let me take this function. You know, function can look all kind of ways. All right. And for each one, we will decide whether it's one-to-one or not. So the first function, is it a one-to-one function? Watch here, the domain, you know, I have piece of it. So the domain here is, according to my picture, is 0, closed as 0, and plus infinity. Is this function one-to-one, yes or not? If yes, justify. And if not, you know, then everybody tells me, I mean, not everybody, only Elizabeth, I want somebody else. Is it a one-to-one? It means, is that a way you can find two input that brings up an output value? Yes, absolutely, only one. So every y have exactly one x that comes from it. That is, sorry, one-to-one, absolutely. That's really the idea. Now, graph 2, is it a one-to-one function? Again, absolutely. Every y, there is a unique x that comes from it. Every y, there is a unique x. So I can construct the inverse. Otherwise, I won't be able to. Finally, of course, the last scenario, so this is a one-to-one. And finally, the last scenario, obviously, this is not one-to-one. So graphically, it's really easy to tell what it's one-to-one or not. So if I take a value here and I tell you what's f inverse, there is no way you can construct f inverse because this output comes from several inputs. There is no way f inverse exists as a function. Okay, so many repetition in the last graph. All right, so every one-to-one function. So this will put restriction on the inverse. It means we cannot always talk about the inverse. We can talk about the inverse only if we have really a nice graph. Our function is one-to-one. That's really the idea. So we summarize this. So if f is one-to-one, so that's really the simple idea. So if f is one-to-one on its domain, of course, on its domain, otherwise it doesn't make sense, then f has an inverse. It means we can construct an inverse that take the input back to the output. Okay, the last idea we will see in here is if I give you, if your function has an inverse, I mean, if your function is one-to-one, and I give you the graph, you know, we just stare at it and moving backward, we can really find the inverse. Now, if the function is given by a formula, and let us find the inverse. So I start with a simple example, very simple example. So how to find the inverse, how to find basically a formula for f inverse. That's really that. All right, let's start with a straightforward example to help us really understand the picture. Actually, yeah, the first one. So I have, let me take f of x to be, let's say, a fairly simple function, x to the power 3. Okay, now the graph is again, the graph of x cubed goes, you know, this is the typical graph of x cubed. Okay, so from the graph, we know that this function definitely has an inverse. So my first question is, find f inverse. I'm not asking for a formula. Find f inverse of, let us say, I don't know, 7. What is f inverse of 7? Okay, what does this mean? 7 is here. Okay, find f inverse of 7, it means what is the input that give me an output of 7? That's really what I am asking for. Very good. So it means we need to find the value of x, that's what we need, such that f take x into 7. So finding f inverse of 7, it means I have to find the input that spits out an output of 7. All right, this is basically hard. It means, I'm sorry, this is basically easy because I need to find the x such that x to the power 3 is equal to 7. That's really what it boils down to. So it means I need to solve for x. So to solve this one, it means x is cubic root of 7. All right, so that's really what it is. Now, the idea is, if I tell you find f inverse of any number, of 100, of course you will do the same. So which input go to 100? Means you find x such that f of x equal 100. And then you find to solve for x and you get the cubic root of 100. So now finally, the second question is find the formula for f inverse. What does it mean find the formula? Find the formula, it means instead of finding f inverse of 7, f inverse of 8, f inverse of every number, can you give me a formula so that if I know the input here, I know what the output is going to be. So find f inverse, find a formula for f inverse. So for me, that's the picture. It means I'm asking you the following. If I take any y in here, any y value, what's the x that would spit out the y? That's really what it means. So finding f inverse, it means we, given y, so we know what y is, we need to find the x such that f of x equal to y. Okay, so finding a formula, it means I need to find the input as a function of the output. I need to find x as a function of y. So let's find x as at f of x equal to y. So it means we're going to set x cubed equal to y and solve for x. That's what we're doing. We're solving for the input. Okay, x cubed equal to y, and I need to solve for x. It means x is the cubic root of y. So if I know y, this here is nothing more than the cubic root of y. So finding a formula, it's really means finding the input as a function of the output, finding x as a function of y. Now notation, 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 notation. Okay, if I want to use function notation, how shall I write f inverse? It's going to be a little bit confusing, but not shouldn't be not. Suppose I use the letter f. So what does this mean? F inverse of y is equal cubic root of y. So using f function notation, it means f inverse of y is a cubic root of y. It means that f inverse take whatever input here back to cubic root of y. Now, if you want to use, sometimes a lot of people write f inverse by giving this variable, instead of giving it the name y, they can give it x, for example. So if we use the symbol x, if you want, the symbol x for variable, I can write f inverse of x to be cubic root of x. Now, question to you. Are those two functions the same? Yes or not? Suppose I give you a function, I use y. Or I give you the function, I use x. Am I talking about the same thing? Yes or not? Yes, Luke said yes. Anybody else? Does it matter what I call? Absolutely yes, because what a function is defined by is but what it does, not by the letter we use. So whether I write f inverse of x equal q, or I write f inverse of t is the cubic root of t, by any of them, all those are actually the same thing. The rule is to cube the input. Whether I write y, x, or t, it doesn't really matter. Now, usually when I teach face-to-face, I usually use y, but because you're using my lab is using x for the variable. So I want you to be aware of that. I personally don't care which name variable you use, but because my lab using x variable, I will actually, I want you to be aware of that. But that's the x is really meaningless, it's a dummy variable. What matters is the rule, and the rule is the cubic one. We expected this because that's exactly how we get that here. All right, now let's take another problem in a very automatic way, so fairly simple way. My question is now example number 2. Let me take the function f of x equal 1 over x minus 4. Now, if we graph this, if we graph it to make sure it is 1-to-1, we get very soon you guys will know how to graph this, some of you do. So we get something like that. So the graph is going to be something like this. Okay, which is absolutely a 1-to-1 function. That means that, I mean, 1-to-1, sometimes you write this symbol for it. It's a 1-to-1 function. So we have an inverse. So my question is, let us find a formula for the inverse. Okay, so what does it mean? In my mind, it means if I know the output, my formula should give me what's the input that comes from it. That's really what it is. So the way we do it, we're gonna set f of x equal y. It means I know y. And solve for x in terms of y. Because I want to emphasize the idea, and that's what we are doing, is we're finding the input as a function of the output. Means I know the y. F inverse is a way to tell me, okay, what is the input? That's really the way we set it up. So we set f of x equal to y, and we solve for x in terms of y. I'm not changing y for x, x for y at the beginning. What I'm doing is what I'm understanding. I have the y, I need x as a function of y. So it means f of x is 1 over x minus 4. It means we're going to set equal to y and solve for x. X is my unknown in this problem, and y is the known. All right, at this stage, it's an algebra problem. Well, how would you like me to do it? So I give you 2 minutes to do it yourself. I don't know how you guys are going to do it. So I give you a minute or so to interact with it, and then I'll take it from there. So if you have a piece of paper, just jot and see how would you do this type of problem. Okay, idea, anybody who was able to get it? Okay, Elizabeth, anybody else? I got that too, very good. Okay, 1 over x plus, yeah, look, I know you're right, but first I want you to set it up my way. Now, I know what you're doing, because I really want to emphasize that it's the why you know and you're finding the input. So I wanted to understand the meaning of what you are in the process of doing, even though the answer is correct. All right, so how's the algebra? So how can I solve for x? What will be our first step? Can anybody unmute and tell me what would you do? Remember, this is the unknown. X is the unknown. That's the unknown. That's the one I'm after. So how shall I start solving?
Products and switch to x minus 4 and the y.
Speak up.
You can use cross products and switch
Cross
to
products.
x minus 4 and y.
Yes, yes, that's what I want. So we cross product. This is 1. So this is gonna give me 1 equal y times x minus 4. Or you multiply by x minus 4 both sides. So either cross product, as your classmate said, or you multiply by x minus 4 both sides, basically to get rid of this denominator right there. What do you want me to do after that? What would you like me to do? We can go 2 routes.
I just switched to x minus 4 and the y, and I didn't just multiply it.
Right. Okay, so one route is we divide by y. So we can, in a way, we're after isolating the x's, so we can work with it. So we divide by y, which will give me 1 over y equal x minus 4. And now we solve for x. X is 1 over y plus 4. So now what is the formula for f inverse? And then it depends which variable you want to use. So if I said y, it means what f inverse does, it takes y, 1 over y plus 4. So if you use y as the name variable. If you want to use x as the name variable, it's okay with me. It will become 1 over x plus 4. if you want to use, I don't really care, n as the name variable, it's okay with me, but you have to be careful. If you use n is your name, you can write it this way. And the idea that the name you assign to the variable, it's not really what matters. What matters is the rule. The rule is whatever you give it, it take 1 over it plus 4. So it's the rule that matters, not really the name of the variable. So let's see in what does it mean in terms of our picture. So let me draw the graph of f now. So that's f of x, 1 over x minus 4. And this was my graph. So there is a certain asymptote here. That's really how my graph looks like. Something like that. So what does this formula tells me? Suppose I have 7 here. Okay. What is the value here? What is this value here? Without a lot of math, what is the value? What's the input that brings up an output of 7 in this particular scenario? Anybody? Because you have to understand, what does this formula represent in terms of the picture? But this formula tells me that if you know the output, this formula will give you the input. So it means if this is 7, what this should be? 1 over 7 plus 4. Okay, that's really what this formula, which is, as Gavin is telling us, it's 1 plus 28. It means 29 over 7. Absolutely correct. That's really what the inverse is. It means I know this here. I know my output. And now I have the formula to go back and to find the input in terms of it. Okay, so if I pick here whatever, minus 8, it means this one here has to be minus 1 over 8 plus 4. Okay, that's really what it does. All right, so finding the formula is really an algebra problem. It's not really a hard problem. Understanding what does this mean is really what matters the most. Now, something that we should know about the inverse that I will finalize this is the following. Suppose I start with an x. Actually, let me go back to this. A table, which make it easy to understand. Let me go back to the table I started with. So suppose this is takes 1, 3, 5, 7. Suppose this is my function. And let me assign, I don't have to assign the same thing I assigned at the beginning of the lecture. Suppose I assign a 2. Let me assign here a 7. Let me assign here a 10. And I'm going to assign here a 12. All right, so that's really my function. Now, does this function have an inverse? So this function that's given by this table, does it have an inverse? It means, is there no two input have the same output? So all the outputs are different. It means this function absolutely have an inverse. All right, so let us here draw the graph for the inverse. So now the inverse, suppose I call this is a y and that's the f inverse values. So it takes 4 input, 2, 7, 10, 12, and 2 is a 1, so we're reversing the process. So f inverse, basically what it does is to undo what f did. So that's what f inverse. F takes 1 to 2. What f inverse will do, it takes 2 back to 1. So it's just like whatever f does, f inverse get rid of it. F takes 3 to 7, then f inverse will actually take 7 back to 3. So it's actually undo what f does. Undo what f does. So that's how you can think of inverse. So it just undo everything that the function f does. So now my question is the following. Now, suppose I look at the composition. F composed with f inverse. So I'm composing those functions. Let us actually, I want to take the other one because it's easy for now. Suppose I take f inverse composed with f of any input x. What should we get? What should we get? And does it make sense? Let me take the problem here and let's compute this composition. So what is F inverse composed with F of 1? In my example, right there, in my example. And why the result should not be surprising. It's F inverse of F of 1. Okay, what is F of 1 in my problem? It's 2. It means it's F inverse of 2. So F takes 1 to 2. What's F inverse is going to do now? What's F inverse going to do? It's going to take 2 and do what F does, back to 1. So this is going to be 1. But that's exactly what F inverse does. Okay, let's compute F inverse composed with F of 2. Sorry, of 3. Because there is no input of 3. Again, what do you expect the answer to be? What do you expect the answer to be? 3, because that's what's happening. Because F will take 3 to 7, but what F inverse do is whatever F does, it undo it. It takes it back to 3. So this is actually why I am telling you that, because that's really important. So if you have an inverse function and you compute F inverse composed with F of anything, of X, this should give us what? This should give us what? It has to give us X back, because that's really what's happening. So F act on something, it gives me the Y. F inverse takes the Y back to the starting point. So F inverse composed with F is equal to X. So you have to think always F inverse as really in doing what F is doing. So intuitively, that's very intuitive, without solving. Suppose F of X does the following. It takes 2 times X, just for this simple problem. What do you think F inverse would do? So let me use for the variable Y. What do you think F inverse will do? It split it, exactly, because if F takes something to 2X, that's F. What F inverse is going to do is basically undo multiplication by 2. So it's going to half the input. So half of 2X, which gives me the X. That's what inverse do. So it basically undo the operation. So it's going to be half. Right? So that's the idea of inverse for tomorrow. It's simple. This time for tomorrow, your homework will be on MyLab. And as I said yesterday, MyLab will be graded for now. The due date. Now I have to give you due date because I'm afraid if I don't give you due date, you will not do them. So I have to put some restriction. So the due date I decided to do, and I think this would be fair. If it's not fair, you let me know, is Friday at 11 p.m. at night. Okay, this is the due date. But you guys know that Friday morning you will have an exam at quiz, so you have to do them earlier. So my advice to you is the following, that I will assign MyLab, do them today. If you have questions as usual, we can work on them tomorrow. And then you guys will finish the MyLab so you can do them correctly. And the second day, I will do the same. I assign another MyLab. So the idea is that if you didn't know how to do it, I don't want you to be penalized. The idea that if you don't know how to do it, you ask me questions, we work on it, and then you guys go and fix your mistakes. That's really. So, but if I don't give you due date, I'm afraid that you guys will not do them. So I decided that I would give you due date. The due date will be Friday at 11 p.m. So you will have, you couldn't do them for tomorrow, let us say, you just glance at them, you have plenty of time to do them. So 11 p.m. on Friday, that will be the due date for your MyLab for the whole week. That's how it works. So every week, the due date will be 11 p.m. But please do them daily, because when I answer your questions, tomorrow I'll answer your questions about today's homework. But let us say on Friday, I will not answer questions about today's homework. Otherwise, you will be always behind. Okay. One more word about the F inverse, and then we're done, of course. So F inverse, we've been talking about the whole hour, is a function that takes the output of F back to its input. Okay, that's really what says a new function. Now, usually I talk a lot about it, and then after later on, the student will do this mistake, which is a fair mistake, but I have to address. F inverse of X is not 1 over F of X. Okay, I know that 2 to the minus 1 is a half. I'm aware of that. So it's very natural for the student when they see minus to take 1 over F. Now it's the notation, mathematical notation is bad, but that's what it is. So we have to accept. So F inverse is not 1 over F. They are not related by any stretch of the imagination. F inverse is a function that takes for input the output of F and assign to them the input that they came from. Okay, so please do not do this mistake. All right, I finish at this note. And if you guys have any issues, please come to my office hours and I will take care of them. Bye-bye for now. And please do your homework on my lab. I will put it in a minute or so.